Hey everyone, and welcome back to the channel. Today we're diving deep into a topic that's the secret sauce behind almost every fast, responsive application you use: caching. Have you ever wondered why an app or website loads instantly the second time you visit it? Well, a lot of that magic comes down to smart caching. So, what exactly is it? Simply put, caching is like creating a shortcut. Instead of going the long way to fetch data every single time, an application stores frequently accessed information in a fast, temporary storage area called a cache. This means the next time you need that same data, the app can grab it super quickly, making everything feel snappy and smooth. Think of it like this. Imagine you're a chef in a busy kitchen. The main pantry, where all the ingredients are stored, is like your primary database. It has everything, but it might be far away and take time to walk to. Now, imagine you have a small fridge right next to your cooking station. In this fridge, you keep the ingredients you use most often: onions, garlic, olive oil. This small fridge is your cache. When you need to sort some onions, you don't have to walk all the way to the main pantry. You just grab them from the fridge right beside you. It's faster, more efficient, and lets you serve dishes or, in our case, data much more quickly. That's the core idea of caching in a nutshell. So why is this so important for application speed? Well, modern applications handle massive amounts of data. Every time you refresh your social media feed, load a product page, or check the weather, your device is requesting data from a server. This server might have to run complex queries on a huge database to get you that information. Doing this from scratch every single time for every single user would be incredibly slow and inefficient. It would put a massive strain on the database and the network. Caching steps in to relieve this pressure. By storing the results of common queries or frequently requested data closer to the user, we can bypass the slow database lookup process altogether for many requests. This not only makes the app feel faster for the end user, but also reduces the load on the back-end systems, making the entire infrastructure more scalable and stable. Let's explore some of the different types of caching you'll encounter in the wild. One of the most common is browser caching. When you visit a website, your browser downloads all sorts of files, images, style sheets, scripts. It then stores these files on your local device. The next time you visit that same site, your browser doesn't need to re-download everything. It just loads the files from its local cache, which is why subsequent visits are so much faster. This is client-side caching happening right on your own machine. Then we have server-side caching. This is where things get really interesting for developers. One popular technique is database query caching. If many users are requesting the same information, like the top 10 trending articles on a news site, the server can run the database query once, save the result in a cache, and then serve that cached result to everyone else who asks for it. This avoids hitting the database repeatedly with the same expensive query. Another server-side method is full-page caching. This is common for static content, like a blog post or an About Us page. The server generates the entire HTML page once and then stores it. For subsequent visitors, it just sends the pre-built page, skipping the entire process of building it from scratch. A more advanced and powerful form of caching is using a Content Delivery Network, or CDN. A CDN is a network of servers distributed geographically around the world. When you use a CDN, it caches your application's static content like images, videos, and CSS files on these servers. So, when a user in Tokyo requests a file, they get it from a server in or near Tokyo, not from a server located in New York. This drastically reduces latency, which is the time it takes for data to travel across the network. It's like having mini warehouses of your most popular goods all over the globe, ensuring fast delivery no matter where your customers are. Major companies like Netflix and Amazon rely heavily on CDNs to deliver their content smoothly to millions of users worldwide. Now, let's talk about some popular caching technologies. You've probably heard names like Redis and Memcached. These are in-memory data stores, which means they store data directly in the server's RAM. RAM is incredibly fast, much faster than traditional disk-based storage. Redis, for example, is often called a data structure server because it can store not just simple key-value pairs, but also more complex data types like lists, sets, and hashes. This makes it extremely versatile. It can be used for caching, but also for things like real-time leaderboards, session management, and as a message broker, Memcached is a bit simpler. It's a high-performance, distributed memory object caching system, primarily used to speed up dynamic web applications by alleviating database load. Both are fantastic tools for implementing a robust caching layer in your application. But caching isn't a silver bullet. It comes with its own set of challenges. The biggest one is cache invalidation, often cited as one of the hardest problems in computer science. The question is, when do you clear the cache? The data in your cache is a copy. What happens when the original data in the database changes? If you don't update your cache, you'll be serving stale, outdated information to your users. This could be a minor inconvenience, like showing an old profile picture, or a major problem like displaying the wrong price for a product. There are several strategies for dealing with this. One is time to live, or TTL. You simply set an expiration time for each piece of data in the cache. After, say, 5 minutes, the data is automatically removed. The next time it's requested, the application will have to fetch the fresh version from the database and recache it. This is simple, but you might still serve stale data for that 5-minute window. Another strategy is write-through caching. Here, every time data is written to the database, it's also written to the cache at the same time. This ensures the cache is always up to date, but it adds a bit of latency to the write operation. A third approach is cache-aside, where the application logic is responsible for managing the cache. The app first tries to get data from the cache. If it's not there, cache miss. It gets the data from the database, puts it into the cache, and then returns it. The application is also responsible for explicitly invalidating the cache whenever the source data is updated. Choosing the right caching strategy really depends on your application's specific needs. You have to balance speed, data freshness, and complexity. For a personal blog, a simple time-based cache might be perfectly fine. For a high-stakes e-commerce platform, you'll need a much more sophisticated strategy to ensure price and inventory data is always accurate. You also need to think about what to cache. Caching everything isn't practical or efficient. The best candidates for caching are data that is read frequently but changed infrequently. Think of user profiles, product catalogs, or configuration settings. On the other hand, data that changes constantly, like real-time stock prices, might not be a good fit for traditional caching methods and may require a different approach. So, how do you get started with optimizing your application using caching? The first step is to identify the bottlenecks. Use profiling and monitoring tools to figure out which parts of your application are slow. Are certain database queries taking a long time? Is your server spending a lot of time rendering the same pages over and over? Once you've identified the slow spots, you can start to formulate a caching strategy. Start small. Maybe implement browser caching for your static assets. First, it's often a quick win. Then, you can move on to server-side caching for your most expensive database queries. Experiment with different tools like Redis or Memcached and different invalidation strategies. Remember to measure the impact of your changes. Does the cache actually improve performance? By how much? Optimization is an iterative process of measuring, implementing, and measuring again. In summary, caching is a fundamental technique for building high-performance applications. It's all about storing frequently accessed data in a fast, temporary location to avoid slow, repetitive operations. From simple browser caching to complex, distributed in-memory caches using Redis. There are many layers and strategies you can employ. While it introduces challenges like cache invalidation, the performance gains are often massive, leading to a faster, more responsive experience for your users and a more scalable and resilient system overall. It's the invisible engine that powers the modern, speedy web we've all come to expect. I hope this deep dive into caching has been helpful. It's a huge topic, and we've only scratched the surface, but hopefully you now have a solid understanding of the core concepts. If you enjoyed this video and want to learn more about building fast and scalable applications, make sure to hit that like button and subscribe to the channel. Let me know in the comments if you have any questions or what other topics you'd like to see covered. Thanks for watching, and I'll see you in the next one.